You ever just stop and think about the invisible systems that make our modern world, well, work? There's this incredibly powerful silent engine running underneath almost every single thing you do online. So let's pull back the curtain and take a look. I think this sailboat is the perfect way to picture it. It looks so graceful, right? Just gliding across the water. But you know that underneath, there's an expert crew constantly at work, managing everything to keep it moving perfectly. That is exactly what a database does for our digital world. It's that hidden crew managing an entire ocean of information so that everything just flows.
I mean, really, think about it for a second. How is it that your phone can sift through tens of thousands of your photos and find that one specific picture from that one vacation 5 years ago in like less than a second?
Or what about your bank account? How does it show a transfer instantly, and how is it always 100% accurate down to the last penny every single time? And get this, how can millions of us, heck, sometimes billions of us, be online at the exact same moment, all posting, shopping, and streaming, without the entire internet just collapsing? Well, the answer isn't some flashy new app you just downloaded. Nope. It's a foundational concept, something developed decades ago that brought real order to the digital chaos. Today, we're talking about the database. And to really get why this was such a revolution, we gotta go back in time. Before databases, trying to manage information on a computer was, well, it was like having a massive, messy, and totally disorganized digital file cabinet. So picture this. It's the 1960s. You're at a university. The registrar's office has one computer file for student grades. The bursar's office, they've got a completely separate one for tuition payments. And the housing department has yet another file for who lives in which dorm. All separate, all totally disconnected. And this, well, this created a world of problems. If a student moved, you just have to cross your fingers and hope that somebody updated their new address in every single file. What if two clerks tried to sign up students for the last spot in a class at the exact same time? The final count could be totally wrong. And asking a simple new question like, hey, show me all the history majors who live in this one dorm was an absolute nightmare. You'd literally have to get a programmer to write a brand new piece of software just for that. I mean, look at this. This really shows you the incredible leap we made. We went from a system that was fundamentally messy, duplicated, and just not reliable, to one that's organized, centralized, and secure. This wasn't just a small improvement. It was a complete paradigm shift. So, what was the brilliant solution to all this chaos? It was the invention of something called the Database Management System, or DBMS for short. This is the hero of our story. At its core, a DBMS is pretty much what it sounds like. It's a system for managing data. But the two magic words here are conveniently and efficiently. It's the software layer that sits between you and the actual data, acting like a super smart, disciplined gatekeeper. And here's the absolute key. The DBMS was designed to solve every single one of those problems we just talked about. It creates one central, reliable source of truth, so that a student's address, for example, only exists in one place. You change it there, and it's instantly changed for everyone who needs to see it. But how does it actually pull this off? It's not magic, not at all. It's built on a few incredibly clever ideas. So let's pull back the curtain and look at the three biggest secrets that make it all work. All right, secret number one is a concept you actually use every single day without even realizing it: abstraction. The whole point is that the system hides all the messy, complicated details so you don't have to worry about them. Think of it like driving a car, right? At the very top, the view level, you're just using your banking app. That's like driving. You don't need to know anything about the engine. Then there's the logical level. This is where the app developer organizes the data into useful ideas like customers and accounts. That's like knowing that the steering wheel turns the car and the pedals make it go or stop. And then way down at the bottom is the physical level. This is the nitty-gritty of how the bits and bytes are physically stored on a hard drive. That's the engine itself. The database hides these lower levels, and that's what lets developers build amazing apps so incredibly fast. Okay, secret number two. This one is all about having a really elegant but super powerful way to structure all that data. The most successful idea, the one that powers most of the systems we use today, is called the relational model. And you know what? It is shockingly simple. All it does is organize data into simple tables with rows and columns. kind of like a spreadsheet, but a spreadsheet on steroids. This table of university instructors here, for example, has a clear, predictable structure. Every single instructor has an ID, a name, a department, and a salary. This simple idea of tables was the breakthrough that made data so much easier to work with. Okay, so you've got all your data neatly organized in these tables. But how do you talk to the database? How do you ask it questions? You need a common language. See, the big problem with those old file systems was that every single new question required a custom-built program. The database revolution gave us a universal way to ask these questions. And that language is called SQL, which stands for Structured Query Language. Now, I know this might look like scary computer code at first glance, but just listen to it. Select the instructor's name from the instructor table, where the department name is history. See, it's practically plain English. This kind of language lets developers just state what information they want without having to write a complicated program for how to get it. The DBMS figures out the most efficient way to find the answer all on its own. It was a total game changer.
Okay, so we've seen the old school data chaos and we've seen the elegant ideas that solved it. Now let's connect all the dots and see how this hidden engine is powering the world you and I click through every single day.
Here's where the rubber meets the road. You know that guarantee that your money transfer either fully completes or doesn't happen at all so it never gets lost in cyberspace? That's a concept called atomicity, the magic that keeps your bank balance correct even when thousands of people are making transactions at the same time. That's concurrency control. The fact that the payroll department at the university can't see student grades, that's the built-in security. And all those apps on your phone, they exist because abstraction and SQL make it possible for developers to build them quickly and reliably. So these foundational ideas solved the huge data chaos of the 20th century, and they became the invisible bedrock of our digital world. But today, right now, we're facing a brand new data explosion, one that's driven by AI and billions of connected devices all over the planet. And that leaves us with a really big question. What unseen engine is going to be powerful enough to manage the data challenges of tomorrow?